Thanks, everybody. It's great to be here. Thanks all for joining our session. It's a very interesting experience. All of you have the headphones on. I think our previous speaker also had the same experience. And we're very happy to talk about LocalStack today, and especially how it integrates with Docker and how we leverage the whole ecosystem. So just by means of quick introduction, my name is Waldemar. I'm the CTO and co-founder of LocalStack. I've been with the project since kind of the early days when it started as an open source project, and it's been ramping up quite interestingly over the last couple of years. And I'll let Harsh introduce himself briefly as well.
Hi everyone, my name is Harsh. I have been working with LocalStack for the past 1.5 years. I guess it has been quite a fun ride, and it is our pleasure to present at DockerCon and just talk about how you can build cloud apps locally with both LocalStack and Docker. So,
awesome, thanks Harsh. So before we actually start and kick off, just a quick mini service so we get a feeling for the audience. So can you just get a quick show of hands of who has experience with public clouds, either AWS, Azure, GCP, so either in a hobby setting or even in a professional setting. So I believe it's about half the people in here, okay. Have you heard of or worked with LocalStack before? Show of hands. Okay, there's a few, it's maybe like 20% or so. And if you're using cloud, what are you primarily using to run workloads? Is it virtual machines, EC2 or the likes, okay? Function as a service like Lambda or Azure functions, also majority. And then Kubernetes or other container runtimes, yeah, also not a miracle, not a surprise at this conference. Okay, cool, so that's great to see, get a bit of a feel for the audience there. So what I want to cover today is just giving you a bit of an intro into the product, the project, getting started with LocalStack. We also want to do some live demos, so hopefully the demo gods are going to be with us, and then dive a bit more into some more advanced topics that we've been working on. One is called Cloudport. It's a feature that allows team collaboration and sharing the state of your instance, and then also LocalStack extensions, which is a new mechanism that we've put out there recently. Okay, so just kind of to kick things off a bit, what is kind of the background or the current state of developing applications for the cloud, specifically also on your local machine? So some of the challenges that people are facing these days is, we're trying to summarize this here in this slide with the prototypical journey of a developer who is building an application, let's say for AWS cloud, right? So let's assume you want to build a serverless application with Lambdas and DynamoDB, different services. So there's lots of kind of different moving parts that you have to manage, and essentially the way it works is you have to upload every change to the cloud, run a couple of tests, see if everything works. If something's not working, then you have to basically make some changes, upload again. So kind of relatively slow cycles of testing and redeployment. The other thing that we often see is, let's assume you have CI/CD builds with your, let's say, builds for every branch, and then when one of your PR builds is red, right? You have a red build. How can you actually replicate the state? How can you identify the root cause of a failing build that's running in a remote environment? And then also, just thinking about managing dev infrastructure is a kind of a big hassle for large organizations, making sure that you have sandbox accounts for all different developers and that there's no resource conflicts and cleanups are happening and so on. So there's just a lot of management overhead involved as well. So that's kind of just a bit of the context of what we're seeing today in the industry. And generally speaking, obviously, this is very generic, but if you think about the life cycles of developing an application, you first start with your local machine, and especially in the Docker context, you do a lot of local interactions. Maybe you have things like some mocking of certain parts of the application, you run some unit tests, and basically just develop the main logic of your application. Then at some point, there's you have a staging environment or some CI/CD. Typically, what we see is that an identical copy is created of what will later be seen in a production environment. So typically with some infrastructure as code tooling, and typically also some preceding of your environment with some test data, right? So that's a pretty common use case also to, in order to run your tests, you want to have some state to work with. And then, yeah, all the way to production where you just promote and operate your changes, your application. And then maybe some more advanced features like some folks are doing chaos engineering to make sure that the application is actually resilient to different types of faults in the infrastructure. So that's kind of how things are generally moving up the stages from local all the way to production. Now, if we think about what's the different kind of models of what is being promoted, of how you can make local changes versus the remote system that is the cloud. the default model of developing is, you have your local IDE and your application code on your local machine, and you have the remote clouds, and basically every code change is manually deployed to the remote execution, right? So kind of the right-hand side column here is the cloud, the left-hand side is the local changes. And basically, the way how you can interact with your application and inspect the state is application logs, monitoring metrics, maybe some tracing. Essentially, you always have this remote execution. There's a class of providers out there that are actually using proxy mechanisms to give you the impression that you're actually executing things on the local machine, but it's actually like proxying the sort of the code and execution into the remote environment. So there's a few companies like, for example, LocalStack or Lightrun, and also I think Test Containers is following a kind of a similar approach there. Having the local breakpoints, local IDE, but still remote execution in the cloud. With cloud emulation, and this is what sort of LocalStack is currently focusing on, you basically have essentially everything on your local machine with these emulated APIs that allow you to run everything locally, quick iterations, quick cycles. For the local testing loop, you would not need the cloud, but we still obviously recommend using it for your pre-production and staging testing. So it's not a replacement for the remote cloud, but it really helps you shift left in the literal sense of doing a lot of changes on your local machine. Okay, and just looking at it from this point of view of having everything running in the remote environment, it seems a bit like using a hammer to crack a nut in a few cases where you have the full power of the cloud, which is really optimized for production workloads, highly scalable and all that. But if you just want to iterate quickly on a Lambda function or a Docker container locally, then you don't need the full power of the cloud environment. So therefore, it's more specialized solutions like LocalStack, for example, do exist. So again, I think it's been maybe clear already from the intro so far, but some of the challenges that we're seeing and also addressing is just the efficiency with the inner dev loop. We've actually heard about the inner dev loop today already in the keynote from Scott, and I think it's really one of the defining themes also of this conference, where Docker gives you the ability to iterate quickly on your local machine and just embracing that efficiency. Debuggability, again, if you're executing against a remote system, there's only so much you can do. You can't set breakpoints. You have to rely on log output or tracing data. And then also resource conflicts, which ultimately, if you're using the same shared environment and everybody's deploying their changes to the same environment, then there is some intrinsic issues there with overriding each other's changes and so on. So there's this nice XKCD comic here, which we slightly reframed. So my code's compiling used to be the excuse for slacking off, and now it's my code's deploying, because it can actually take quite some time for these changes to deploy to the cloud, which we'll also see in a second from Harsh. Okay, yeah, really cherishing the inner dev loop, I think it's been mentioned, so really making sure that these code builds, test and debug cycles can execute very efficiently on the local machine is really what we're after with the solution we're building. Okay, so I guess with that we'll soon get into what is LocalStack really, but just to quickly summarize, so why would you even run applications on your local machine? Again, reproducibility, making sure that you have an environment that has the same characteristics locally and in your CI/CD pipeline and production, speeds, agility, and then also the reduced management overhead of having to manage less of these cloud dev environments in the remote environments. Last but not least, costs, but that's more of a side effect that's also nice to have. Okay, so with that, I'm handing over to Harsh for some intro to LocalStack.
Definitely. Thanks a lot, Waldemar, for such a great introduction. So hi, I'm Harsh. I will be talking about getting started with LocalStack on Docker. And I guess you have already got a pretty great insight into what exactly LocalStack is trying to solve. So LocalStack, as the name pretty much suggests, it's a fully functional local cloud stack. So just imagine like running a bunch of AWS services, APIs pretty much on your local machine. So if you're doing like compute stuff like with Lambda, Elastic Container Service, Elastic Kubernetes Service, or if you're doing databases, messaging, any sophisticated or exotic APIs, you can pretty much use LocalStack for all your dev and test like experiments, integration, building your applications before you actually push them out to the cloud. So Waldemar, in fact, started LocalStack back at Atlassian in 2017. I guess we do have some history behind the project. And since then, we have like transitioned into a full-blown like software startup based out of Zurich. And this is where we are exactly like building the whole product. And Initially, it was just about AWS mocking and like making sure that you can actually like run these AWS services locally before you like actually push them out to the cloud. But now we are going into full-blown AWS emulation. So it's not just about like mocking those APIs and getting to see the requests, the responses, and all of those things. You can actually get to see like your data flowing in like end-to-end through your entire workflow lifecycle. And this is what we are exactly going to see. Like we have some bunch of other features, like we have the collaboration features like Cloudports. We have some new and exciting stuff that we have not demonstrated earlier anywhere else. So we are just quite excited to showcase that over here. So yes, LocalStack is a drop-in replacement for AWS running on your local machine. I guess like it's a pretty big shot of a statement because AWS is such a huge cloud service provider, and emulating like over 200 plus AWS services, including a bunch of new services that just go GA like every month or so, is pretty difficult. But in our experience, we have like covered up a pretty good coverage of those AWS APIs that a lot of customers happen to use. And we have built out a certain parity that basically allows you to use these APIs in a pretty reliable manner. For example, one of the services that a lot of our customers use is Lambda. And the good thing is like Lambda has an absolute 95% parity with the actual AWS APIs. We are going to see like how we exactly achieve that. But this basically allows you to like run a lot of the complex workloads on your local machine and actually be confident that whatever is running on your local machine, that's going to work on the cloud itself. And one of the things that Waldemar mentioned is the cost part and the speed as well. And this is where exactly we are going to see this. So we ran a couple of benchmarks like over the past few months with some of the complex configurations. So MSK, Apache Airflow, RDS, Aurora, like these kind of stuff. And I guess this is one of the good experiments that kind of showcases how fast LocalStack can exactly get. So we are trying to deploy a managed streaming for Kafka cluster using Terraform on both LocalStack and AWS. On LocalStack, this just gets executed within 24 seconds, while on the actual AWS, this takes around 28 minutes or so. And this is an actual Kafka cluster. You can like integrate this with any other AWS service. You can like get to see how the data is working around here. And I guess this is such a big thing to actually have this in your inner dev and test loop, because now you can just spin up a bunch of AWS resources right on your local machine without having to worry about the cost, without having to worry about the deployment time and all of that. And you can just go ahead, like do crazy stuff with your whole environment, and like you can be pretty much sure that this is not going to break anything onto production. Or this certainly gives you a bit of a confidence on whatever software stack that you're exactly trying to work on. So if you take a look at LocalStack from at 10,000 feet, you will know that LocalStack is not exactly trying to replace AWS. Like AWS is great. It has been helping like startups, companies, big tech, like scale for like quite many years right now. And we believe that AWS is one of the perfect cloud solutions that you can use to build out your production workloads, like build out your actual production apps. But AWS may not be so optimized for your development and testing purposes, because like there are so many problems with this. There is a cost factor, there's a speed factor, there's a factor about having multiple developers having their own developer accounts, trying to like build around with that, mess around with that. And certainly the costs start piling up, and this is when you exactly see that you're burning quite a lot on your cloud spends. With LocalStack, you can pretty much use LocalStack like as a drop-in replacement for AWS right on your developer machine and your continuous integration environment. And once you're pretty much confident that, hey, my application stack is working out pretty well on my local machine and on my CI runners, you can pretty much push to the production, and this is where AWS certainly comes in. It basically helps your application scale, and this is where you can exactly get to see like the benefits of like using LocalStack just for the dev and test purposes. So I guess like this is all about the architecture, so maybe I'll just hand it over to Waldemar. He's going to talk about the whole architecture and how LocalStack basically integrates with the entire Docker ecosystem.
Awesome, thanks, Harsh. Yeah, just to spend a few minutes on how is it actually built. So LocalStack in and of itself it ships as a Docker image. So you can pull the image. It's basically one monolithic container for the most part. It's implemented in Python. So what you see here is the main Python process and some of the components that are in there. So we have the core runtime, which has essentially a central entry point. That's port 4566. Just happens to be the port that we chose for that. Then there's a gateway, which is taking all the requests that are coming in. And there's a bunch of utilities like process utils, request parsing, and so on. And then the gateway delegates to the individual service implementations, right? So we have Lambda, we have CloudFormation, Kinesis. Some of these services actually talking like amongst each other. So CloudFormation, for example, is provisioning resources among all the other services. And this is kind of some inter-service communication is happening there as well. And also, you can see here at the bottom these additional Docker containers for especially Lambda functions and other processes which just spawn as separate containers, which then execute the code on the user's behalf. There's also persistent volume involved, so we have a mechanism called the LocalStack volume, which has the ability to store configs, the state of your application, and so on. So that's on a very high level, kind of the architecture, and it's kind of a pluggable, extendable system that we've built there over the years. And then just maybe looking a bit at sort of the more distant past, even like before we started introducing Docker or using Docker as our deployment and delivery platform. So in the past, we were basically installing all these components on the host machine, right? So you can imagine, if you're in a heterogeneous environment, different operating systems, different Python versions, Node versions, and so on. So that used to be pretty tricky. There's also a security exposure. If you think about like LocalStack is touching a lot of files on the file system, creating temporary files, spinning up processes, and so on. So this was really a bit tricky to do on the host. Also, it was relatively hard to reproduce issues, right? So whenever users reported, hey, something's not working on my machine, then it was always hard to, is that some configuration issue in that environment, or is it something with our software? So really hard to replicate actually the root cause and the issues of customers. And then also networking, I think, is where Docker brought a lot of value to the table. Just thinking about things like custom DNS resolution or just interconnectivity between services was very tricky in the old days. Today, shipping it as a Docker image, things are much more easy and streamlined. So it's a predictable platform, works across different operating systems. We can control exactly which dependencies go in there. And it also provides this container isolation, right? Providing a decent level of security. I mean, we still need to make sure that there's certain security best practices in place, but it's a decent level of security. We have immutable build artifacts, right? So a tagged version on Docker Hub does not change over time, so we can always go back and see, okay, we can reproduce a user issue with a certain tagged image. And then again, like the integrated network stack that Docker provides is really helpful because we do a lot of custom networking these days with a custom DNS server that we integrate. That is really very helpful to have this isolated network within the Docker stack itself, really. So this is just a bit of a background on some of the technology and how we're using Docker. And one example, as Harsh briefly mentioned before, is Lambda. I think it's a pretty interesting service from an implementation point of view. We are actually leveraging a lot of the open source and available code out there from AWS directly. So they have this thing called the runtime interface emulator, which essentially is a local Go implementation of the Lambda runtime interface. It's just an API to spawn containers, like run functions and so on. So we have that in our Lambda containers, and then there's the control plane, the Lambda provider here on this picture in the center, which really uses also the Docker socket that we mount into the main LocalStack container to then spawn these Lambda containers. And then also the DNS comes into play, because if your Lambda function wants to talk to some other LocalStack service like an SQS or DynamoDB, then we actually do the rerouting of these requests to the proper container back to LocalStack. So yeah, Lambda I think is a pretty interesting one, and we're super excited. We got this out with a recent release, and it has very high parity with the real system there as well. With that, over to the installation mechanism via the Docker extension, which we've recently released. So over to you, Harsh.
Sure. So if you want to have a look, then LocalStack can be installed via a lot of mechanisms. So like if you just go to the installation page, we have like a bunch of options over here. And officially, we say that, hey, like if you want to use LocalStack, maybe just use the LocalStack CLI. I guess we are going to use that for a bunch of the demonstrations. But if you want to use LocalStack with some of the Docker products, we have a Docker configuration that basically allows you to run the LocalStack as a Docker image itself. We have got Docker Compose. So basically, you have this Compose stack. So just say Docker Compose up, and that's going to start LocalStack on your machine. Additionally, we have the LocalStack Docker extension that we have been building with the help of the Docker team over the past few months. I guess if you just happen to go to the Docker desktop marketplace, and if you just search for LocalStack right here, I guess it just happens to be like one of the most downloaded Docker extensions right now with over 10,000 plus installs. So yeah, so in this particular demo, like we can maybe just use the Docker desktop extension. And just to highlight, LocalStack has different product tiers. So we have this open source community version. And you can just go to github.com/localstack/localstack, and I guess you can just get to see that. Apart from this, we have some like pricing options. We have the LocalStack Pro for like individual developers or a small group of devs. We have the LocalStack team, which like if your entire team is working on LocalStack, maybe that would be the best option. And we have the enterprise option if you want to use like LocalStack in airtight environments or with some particular specialized use case like chaos engineering. I guess this is the best option right for you over here. So in this particular presentation, we are going to showcase a few of the features that will require an API key. So if you just want to use an API key for the purpose of this whole conference, we have ls-api-23. So you can just download LocalStack as a Docker extension from the Docker Desktop Marketplace. And you can just go to the configurations, and you can just set like an API key right over there. And I guess like that would just allow you to use LocalStack with all of its features enabled for you, like just for this particular conference. So if you want to start LocalStack, you can just go to the Docker extension. You can just click on this handy start button. Yeah?
Just select the right profile.
OK, yeah. So I can just select the right profile that has got the API key enabled for me. And I can just click the start button, and that is going to start my LocalStack Docker container. So as Waldemar already mentioned, LocalStack is shipped as a Docker image. So no matter like what your preferred mechanism is, at the end of the day, you're just spinning up a Docker container. And if you just happen to use a LocalStack CLI, it has got a bunch of additional features that you can use with the container. So I see like I have spinned up the Pro container right over here, and you can just see like we have a lot of AWS services right over here with great deal of parity. So if you want to go and test out some of the parity stuff right over here, we have this pretty simple coverage page. I guess I should have showed this like a bit later, but yeah. If you want to check out, like, let's say the parity for a service like, let's say, S3, because it's something that most of you might have used at one point or the other, you can get to see the parity that we have right over here. And this basically builds a certain degree of confidence in your workloads and what kind of applications you're trying to emulate and like run on your local machine. So yes, LocalStack has a growing ecosystem of integrations. The good thing about LocalStack is like it's not very opinionated. It's a regular cloud emulator. And you can just plug this in with any sort of integration that you really want to use. If you want to work with CI/CD systems, we have got GitHub Actions, GitLab, CircleCI. If you want to work with application development frameworks, we have got Shipyard. I guess Benji's right here. We have got namespace, test containers, SAM, serverless, Copilot. If you want to use this with ISE tools like Terraform, Pulumi, CDK, maybe even OpenTofu, like the new open source project in the town in the future or something like that. So LocalStack can be tightly integrated with all of these tools right over here. And if there is any other tool that basically allows you to change the endpoint URL to point to the custom edge port that LocalStack provides, LocalStack is going to work with that. It literally took us like a few hours to basically add the support for crossplane. I guess Waldemar did that. And it's literally easy to like integrate LocalStack with whatever pre-existing stack that you have. So you don't need to like switch to a completely different framework or a completely different opinionated idea about what local cloud development should look like. You just plug and play with LocalStack, and that's exactly going to work fine. And as I said, LocalStack is a pretty highly configurable platform. So with this particular configuration, you can change the behavior of LocalStack for a bunch of different use cases right over here. For example, one of my favorite use cases like these Lambda configs. So there is a particular feature called as local code mounting. And that basically means that you can actually mount your Lambda function sitting right on your disk to your Lambda code. And once it is deployed, you don't need to update your Lambdas. You don't need to like delete them or like recreate those Lambdas. Every change that you do to your Lambda function will be automatically reflected within a few milliseconds. And this is such a powerful feature for anyone who wants to have a complete hot reloading experience right with Lambdas or with any other AWS service. We have got persistent settings, and this basically means that you can persist your LocalStack infrastructure state. LocalStack is ephemeral by nature. So you start the container, you delete it. None of those AWS resources have existed on your local machine. But what if you want to basically persist some of those resources, like a bunch of S3 buckets or Lambda functions? This is where persistence can basically help you out. So we have like a great deal of configurations, and we are continuously adding new stuff. So you can just go to the docs, and you can check it out. And I guess this would give you a pretty handy like insight into how LocalStack can exactly work out and how it can basically fit in with all of your use cases. So with that said, we have a pretty handy LocalStack web application. And I guess this is something that has been a constant complaint by a lot of people that, hey, LocalStack doesn't have a GUI, and AWS has a GUI. So maybe I just want to click a few stuff. I want to create a resource. I want to do wacky things with that. Guess what? We have the web application right here. And it provides a bunch of new things that maybe even AWS doesn't exactly support. So I can just go to the LocalStack Web App right over here. This is how the web app looks. And one of the famous things that we are doing is like basically these resource browsers. And this is basically like a stripped down version of what AWS Console provides. And this is pretty much handy for all of your local development and testing purposes. Like for example, I can go to S3, I can just go ahead, create a bucket. I can specify a bucket name, I can specify the other settings right over here. And that is going to create a bucket right on my local machine. So none of this is being stored on any of the servers that we operate. Everything is happening pretty much on your local machine itself. We have something called as extensions. I guess I'm going to discuss about that a bit later. We have got something called as CloudStack Insights. And basically, this means that you can have a detailed API telemetry into your running AWS stack. I guess we don't have like a lot of API calls right over here, so we don't see anything. But you can have a detailed API telemetry to see what kind of API calls have succeeded, what kind of API calls have failed, and what are the clients that you have been using or the AWS services that you have been operating on. So pretty cool stuff, right? And with that said, I guess I can hand it over to Waldemar for our official tech demo. So hope the demo gods are with us. So over to you, Waldemar.
Indeed, yeah. I hope the demo gods are going to be with us. So yeah, let's switch gears a bit and just try and play around a bit with LocalStack and just deploy some applications. So we have this sample app, which is also on our documentation, which is a serverless image resizer application. Basically, it has a web UI where you can upload pictures, and then basically what happens is whenever you upload a picture, it triggers a Lambda function that first of all creates a pre-signed URL with S3. And then you can actually use that pre-signed URL to push the file to a bucket, to an S3 bucket locally, and then actually resizes the image to a thumbnail and stores that back to the bucket. And it basically does this with this asynchronous event-based processing logic that the S3 bucket notifications are providing. All right, so let's switch over to our terminal here. And in the right directory here, LocalStack has been started. So I'll just run this bin deploy sh script. And let's take a look at what this actually does. Let's bin deploy sh. So what's happening here now is there's a bunch of steps that we're taking. They're all using this AWS local command line interface. I hope you can actually read that also from the back. So AWS local is just a drop-in replacement for the AWS CLI. So we're creating a bucket. We're creating some SSM parameters. We're creating an SNS topic that was on the list there before. We're creating Lambda functions. So Lambda functions is the code that actually executes. They are written in Python in this case. And then a bunch more sort of boilerplate to get this application running. One interesting aspect is here, for example, we're building a Docker image, or we're actually compiling some of the code because we're using a Python library called Pillow, which does the image resizing. And for that, actually, we need to spin up an ephemeral container that does the compilation for that particular architecture, for that particular Python version. And then it builds the Lambda zip file, packages it all up, and then uploads it to LocalStack. And then a bunch more steps, and towards the end, it just outputs the configuration of this application, right? So the script is now done. We can head over here, and actually tells us to open this page here, open this web app under this URL. So we're just going to go to our browser. I believe it's already open somewhere. It's right here. So we're just going to refresh this page, and then we say load from API. So it's basically now fetching what is called the Lambda function URLs. So those are actual endpoints that we can invoke locally. So you see that they actually have this localhost.localstack.cloud domain name, and any subdomain of that basically resolves to a localhost IP address, 127.0.0.1. So if you invoke this endpoint, it just calls the LocalStack instance. So what we can do now here is we can just go ahead and upload a file. I think we have some DockerCon screenshot. I'm going to say upload. And what's happening now is if I quickly, just wait a second until this is done. And if I quickly switch over to Docker in the meantime, what we should be able to see, to Docker PS, you actually see that the Lambda function have spun up here, right? So this is a separate function that is using this Python runtime, and it's now basically done the process of, at least I would hope, that it did. Okay, it's probably the demo effect here. Ah, interesting. Okay, so let's give that another quick try. Just going to stop and restart LocalStack. Obviously, the demo gods are with us. Okay, we got the right config here. starting it up again. So we got a fresh instance. Then I'm going to do another deploy here. Which again creates all these different moving parts, SNS, topic, Lambda function, and so on. And now hopefully this is actually going to work. So it's now building the pillow library, as mentioned before. And once that's done, deploys the function URLs. Okay, let's go back to the interface here. And if I do try this another time, select the file, screenshot, and then we upload it. Okay, this time it was success. I believe maybe some network hiccups before. And then it's actually showing us the resized image. So it initially was something like 4 megs, and it was downscaled to 340 kilobytes. So again, relatively simple application, but it's nice to kind of see end-to-end. So you have a web UI, which is hosted in a local S3 bucket. We have a bunch of Lambda functions, and they're all stitched together. And again, all of this was basically running on the local machine without ever talking to the real cloud out there. Speaking of which, since Harsh was showing the web UI before, we can now actually go back to our resource browser and just briefly check some of the resources that were created by this sample application. So we just need to, first of all, I believe we need to be in the right, yeah. So here we can see the buckets. So it has our web app bucket that just hosts the assets of the web application. If we go back, we should also be able to see the original images in here, and then the resized ones in the other S3 bucket, right? Those are the resized ones. So this is at the S3 view, and we can also see if we go to Lambda here, for example, for a quick second, the functions. And for example, if you go to pre-sign here, you can even check out the logs. It gives you like all the insights into, okay, you know, those were the invocations. Similar to what you would see in the AWS console, you can actually just drill down into the logs here and see, okay, this was actually executing in this Lambda function. So kind of handy, another way to interact with these resources on your local machine. All right, so that was a quick demo. Glad that the demo gods with us. Let's go back to our slides. Sorry for switching back and forth here. I believe we need to go here. Just a sec. It's a bit hard to get back into the full screen mode. I won't get us over here. Oops. Yep. That's the other screen there. All right, there you go. Okay, so we've done this, right? We've resized some images, so kind of nice little sample application. And what Harsh is now going to show us is, you know, how we can actually use the ephemeral state of the container and actually persist the state and share it with our team members with Cloudpods, our Cloudpods feature. There you go.
Awesome, nice demo. So I guess like we can get started with understanding about how you can actually save your infrastructure state by Cloudport. So Cloudports is a technology that we started investing in like maybe a year and a half back, so something like that. And what Cloudports basically enable you to do is making sure that you can actually persist your local stack state and you can share it with all of your team members. Now, before Cloudports, we had a mechanism called as snapshot persistence. So basically what you can do is like you can configure a variable called as persistence. You can just set it as 1. And this would ensure that whenever you restart your local stack instance, all of the resources that you have created previously is loaded into the instance, and like you can get started on using them. You don't have to like create them manually all over again. But this had like a few troubles. Like the very first one was that you cannot exactly share this persistent state with anyone else in your team. And maybe you want to do some collaboration, maybe you want to do some preceding, maybe you want to do it for reproducibility, something like that. And this is where we decided to take like Cloudports into action. And Cloudports basically allow you to like take like point-in-time snapshots of your local stack application state. And you can use this to like preload your running local stack instance on any other computer or any other CI runner. And in this way, you can basically share it with your team members. You can like use it to like for your CI environment, and you can use it for a bunch of other use cases that we are going to showcase right now. So how persistence basically works is like, if you're using persistence, you have the local stack instance, you have like a bunch of AWS resources like Lambda, SQS, S3 bucket. And local stack basically continuously stores all of that state to the disk. And whenever you restart your local stack instance, we basically reload the state, and you can just continuously start to use the same state all over again. How Cloudports basically work is like you have the local stack instance, and once you exactly say that, hey, I want to save this point in time instance right now, you can just use it with LocalStack pod save. This is going to create a Cloudport, and this is going to upload it to the LocalStack platform, which is a web application that you just saw right now. And if you are working with a particular team member, like your other team members can basically just say like, hey, I want to load this particular Cloudport, so you can say like LocalStack pod load, and this is going to inject all of that previously created AWS resource back onto the running LocalStack instance that we have right over here. So this is exactly like how it works. We have our own protocol of like creating and saving these Cloudports and sharing it across with the team members. And this is something that we have been like fleshing out for the past few months, like improving the whole user experience and making sure that more and more users kind of get accustomed to this Cloudports to basically share like all of these cloud resources in some persistent shareable sandboxes. So we can take a quick look on how you can manage the state by Cloudports. I guess we have a very small demo for this. We will create a bunch of AWS resources. We are going to create a Cloudport, and we are going to restore it. I guess nothing really fancy, but let's see what we have got right over here. So in this case, I guess I can just go and like maybe stop my local stack container running over here. And I can restart this. So that's going to load all of the AWS resources that I have right over here. And in this case, so I have like a bunch of like AWS local commands that I can just run like right out of the box. And what I did right over here is that I created like an S3 bucket. I created an SQS queue. I created a Cognito identity provider. And all of these have been created right on my local machine. So if I just go back to the LocalStack logs, I can get to see that all of these have been created, and now we can just get started on using them with our local development workflow. But in this case, our use case is slightly bit different. We want to save all of this instant state in a Cloudport. So what we can do is like we can just go ahead and we can just say like LocalStack pod save. And over here, we can just say like DockerCon state right over here. And what this will do in the background is that you can actually get to see that the Cloudports API have started firing up right now. OK, so these are some verbose logs. So you will see like a lot of information that is not relevant for you. But what is happening right over here is that the LocalStack platform has saved the entire infrastructure state onto the LocalStack web application. So you can see like the DockerCon state has been successfully created. It's version 1, so basically you can actually version your Cloudports. So like if you make some changes to your Cloudport right over here, and you just say like LocalStack pod save once again, that's going to create another version of your Cloudport. And this might work similar to Git. However, the underlying technology is a bit different. But this basically allows you to like do a lot of interesting stuff and like restore these snapshots at any point of time and just experiment with AWS and LocalStack in general. So if I just go back to my LocalStack web app, I guess I'm going to refresh this for a bit. And if I just see the Cloudports right over here, you can get to see that we have this DockerCon state Cloudport right on my local machine. So if I just open this, so I see like the logs over here, the S3, SQS, Cognito IDP, like a ready-made Cloudport available on my local machine. Now, since we don't have another laptop to kind of showcase this feature, what I can basically do is like I can just go ahead, I can stop this Docker extension running, and I can start it all over again. And I can just go back and I can just say the same thing, like I want a LocalStack pod load. Let's say DockerCon state. So this will load the Cloudport right on my freshly created LocalStack instance. And if I just go back to my LocalStack web app, maybe I can go to the resource browser, maybe the S3. You already see that we have not fired up any sort of AWS local commands, but we still have an S3 bucket right on my local machine. So you can share this Cloudport with all of your team members. You can like inject these AWS resources right onto your running LocalStack instance. And this basically opens up a lot of use cases. One of my favorite use cases that I just happened to discover today is how you can create ephemeral instances using Cloudports. So I can just go to, the Cloudports over here. I can just click on this. And over here, I can just click on this particular button called as Browse Version. Again, this is the MVP right now. We are going to improve this whole feature set. But once you click on this Continue button, this is going to start a new LocalStack instance. And this is going to create like an ephemeral environment for you that's not running on your local machine. But you can use it to like connect with that, and like you can use it to like create your AWS resource. So you can see like another pod has been created, which is called the DockerCon state. And this is right now running on Namespace. So Namespace is one of the partners that we're working with. So they provide these ephemeral dev environments. And this will basically persist for like a few hours or so. I'm like not exactly sure about that. But now you can actually use this particular URL. And you can basically redirect like all of your AWS API requests right to that. So you don't need to use AWS local. You can just say like, maybe I can just show a quick demo. So yeah, right over here. OK, not exactly this. OK, so maybe I can just say, so I can specify the endpoint URL right over here, which is the namespace URL that we have just created before. And we can just see like S3ls. So as we do that, you can get to see that the test bucket exists on the ephemeral dev environment that we have created right over here. And that means that if you're certainly restricted by any sort of specifications right on your local developer machine, you can inject these Cloudports into some other ephemeral dev environment, and you can just connect with that, and you can get to do all sort of AWS experiments right on the fly. So that's about managing state by Cloudports. I guess Waldemar can talk about like how you can change the remote storage, because as you have seen, like we are saving these Cloudports onto the LocalStack platform. But what if you want to go beyond this? What if you want to save this on S3 buckets or ORAS? So maybe Waldemar can talk a bit about it and just showcase some insights.
Awesome. Thanks, Harsh. I see that we're running a bit out of time, but so maybe I'll just glance over this. But basically, we also have the option to push these Cloudport states to alternative backends. So you can use our managed storage, but you can also push it to an S3 bucket, for example, or, which is also cool for this audience, to an OCI registry, for example. So there's this protocol called ORAS, OCI registry as storage, and we've actually built a connector, a plugin that allows you to push a pod to an OCI registry or Docker Hub more specifically. So we've actually done this before. Again, I don't think we have time to go into this now, but we've done a demo just before the talk. We pushed a pod to a Docker Hub, and it actually, you can see if we open this link here, you can actually see it's in Docker Hub. It's a pod that's here. We see the tags with version 1, version 2. So this is, again, one of the storage backends that we can leverage as an alternative to our platform storage. OK, cool. So I guess moving on to more the concluding part of the presentation. Let me just try and find my slides here. I guess they're probably here. Need to go back. Do I need to go back here now all the way? Let's exit the full screen.
Yeah.
OK. All right. Yeah. So in that sense. And then one of the use cases that's really interesting is like using Cloudports in a continuous integration environment, right? Let's say you want to pre-seed some of your state in a CI build. You can actually just use this mechanism to have a test available for each CI build in a very easy manner. OK, so maybe wrapping up, and I think actually, Harsh, you wanted to briefly show extensions, and then I'll do the final wrap up.
Sure.
Maybe a couple of minutes left.
Yeah. So as I guess like this has been showcased on the web application before, we are building LocalStack extensions, which is basically a way for us to extend LocalStack. So LocalStack, as of now, has been purely focused on AWS emulation, like getting to ensure that you can run your cloud workloads locally. But what if you want to go beyond AWS? Because every time we meet someone, they're like, OK, when are you going to support Azure? Or when are you going to support GCP? And we're not exactly going in that direction. We're eventually evaluating this. But we have made it possible to actually extend LocalStack's behavior by making sure that you can plug in some new services, new functionalities right into the LocalStack. And this is especially useful because you can use it for like a bunch of purposes and like other feature sets. Like you can intercept your service calls. You can do some like chaos engineering. You can like add additional service emulators or endpoints. Maybe if you're interested in Azure or GCP, you can eventually integrate them all into the LocalStack platform. And that's going to run end-to-end right happening on your local machine. So if you take a look at the LocalStack mechanism, so one of the things that we have invested in is kind of this whole extensions mechanism since version 1.0. And we have like a very simplistic extensions API. So maybe you can just go and find it on the documentation, or I'll just share the link with all of you. And with this whole extensions mechanism, you can go ahead, you can create your own extension, and you can like load it into your LocalStack instance. And that's going to like work out pretty spectacularly. To improve the experience, we have been like building this whole new extension dashboard right onto the web application itself. So if you go to the extensions right over here, you can get to see all of the extensions that we have created, like that our team has been working on for the past couple of months. So we have this AWS replicator extension that basically replicates all of your AWS resources onto your local machine, right into your LocalStack instance. We have this really exciting Miniflare extension. So we have been working with the Cloudflare team for the past few months or so. And basically, this allows you to run your dev environments for cloud workers, which happens to be Cloudflare's own fast platform, similar to Lambda functions, right on your local machine itself. And if you want to install one of these extensions, it's pretty simple. You go to this instance, you go to the whole DockerCon state, and you just click on install. And that's going to install the extension right for you over there. So yeah, Cloudflare Workers is one of the most interesting things that we have right over here. So Cloudflare actually has its own emulator right over there. It's called Miniflare. And Miniflare just happens to run on this workerd runtime. And the main problem with this whole thing was Cloudflare API was not extensively covered by Miniflare, and this is when we took up the queue. We decided to build out an extension right on this. And with this extension, you can just simply plug in your worker application with your AWS resources, and that's just going to work out quite well. So after installation, you can just go to this particular URL, and you can get started with building your worker applications right over there. So this is just another step in the direction of extending the main functionality of LocalStack beyond AWS, so that you can actually have a full-blown local cloud dev and test experience right happening on your local machine. So with this, basically, we can wrap up right now. So local cloud development is feasible. I guess we have seen a lot of arguments and counter-arguments about whether local cloud development should actually be done, or is it just an anti-pattern, or is it something that should be abandoned altogether. But in our experience, local cloud development is feasible, though building a cloud emulator is incredibly hard, because we have been working on a lot of AWS services. I guess if I'm remembering this correct, we have over 90 AWS APIs right now. So maintaining them with such a small team is really, really hard. And this has not been possible without the community effort. So not just from our own team, but from AWS team, from a bunch of open source contributors. We have over 400 contributors right now. The project health is pretty much awesome. And a lot of people say the community version is something that they're just happy with. So if you want to try out LocalStack, maybe the community version can be a right start. And if you want to go beyond, maybe you can look into some of the pricing tiers. Docker has been the perfect platform for running a system like LocalStack. I guess I wrote a blog with one of the DevRels at Docker. And one of the things that we mentioned over there is that Docker just so happens to act like a mini cloud operating system for us. And without the help of Docker, this could not have been seemingly possible. Thirdly, we have a great ecosystem to work in. We have seamless integration with most of the frameworks, services, providers right over there. And emulation is just the starting point for us. We are thinking about new methodologies, new technologies, so that we can make sure that you have a seamless developer experience, because that's exactly what we are trying to invest in. So if you want to try out some really complex stuff, we have been working on this developer hub. So you can go to the docs, and you can check out the developer hub right over here. And this basically has a bunch of AWS applications that we have been working on. And if this presentation has not really convinced you, maybe running one of these applications can really convince you out. And this can exactly showcase some of the really complex use cases that you might encounter in your day-to-day workflows, querying data in S3 bucket with Amazon Athena. I guess Waldemar did one of the demos in our community event, and that just blew up the mind for everyone out there. Awesome. So Waldemar?
So final slide, we're wrapping up. So thanks again for being here. We got a lot of really cool things in the pipeline. Excited to work with you all, with the community. I think we've shared a lot of cool, interesting updates today. And also big shout outs to Docker for organizing these events. And just want to mention a few more. Atomic Jar test containers, which we're working with. Namespace and Shipyard, ranges here, and also Cloudflare, as we mentioned. So really looking forward to expanding this set of integrations and partnerships that we've started so far. So happy to take any questions if we have a few more minutes, and thanks again for being here.